Welcome. In part 9, we're going to learn about the prime numbers. For a number to be a prime number, it has to check two boxes. It needs to be divisible by only 1 and the number itself, and it needs to be a natural number greater than 1. If it checks these two boxes, it's a prime number. 1 itself is not a prime number. A lot of people get that confused, so don't forget that 1 is not a prime number. It has to be greater than 1. So let's write down the prime numbers between 1 and 100. This will be helpful if you memorize these numbers, but if you don't, it's still fine. So let's just write it. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 41, 43, 47, 53, 59, we have 61, 67, 71, 73, 79, 83, 89, 89, and lastly 97. These are all the prime numbers between 1 and 100. Also, don't forget that 2 is the smallest prime number. It is also the only even prime number. There is no other even prime numbers. Okay, here's a question and let's solve it together. A and B are positive integers, and A times B equals 13. What is the sum of A and B? So we know that A times B is 13. Well, what is 13? 13 is a prime number, right? If you're multiplying two things and getting a prime number, then those two things can only be 1 and the number itself, which is 13. Could be 13 and 1, 2. It doesn't make a difference. You could also think of -1 and -13, or -13 and -1. But the question here specifies that it has to be a positive integer, so we will disregard them. And the question was asking what is the sum of A and B? Well, 13 plus 1 equals 14, so the answer is 14. Okay, here's a question. What is the sum of the largest two-digit prime number and the smallest three-digit prime number? We're looking for the largest two-digit prime number. If you remember, if you memorized it from 1 through 100, it's going to make your life easier. We know that the answer is 97 for that. But for the smallest three-digit prime number, we can start from the first three-digit number, which would be 100, but 100 is not prime. And then let's cross that out. We have 101. 101 is not divisible by 2. It's not divisible by 3. It's not divisible by 4 or 5 or 6 or 7 or 8. So it's the answer we're looking for is 101. 101. So now we're just going to add them both up. 7 plus 1 is 8, 9, and 1. So the answer is 198. Coprime numbers are pairs of numbers that do not have any common factor other than 1. An example to that would be 5 and 13, because they don't have any common factor. In fact, they're both prime numbers, right? 5 is a prime number and 13 is a prime number. So any two prime number is actually a coprime. It also doesn't have to be two numbers, it could be multiple numbers, but it has to be at least two numbers. So 5 and 13 are both coprimes, 8 and 9 are coprimes. So you might be saying that 8 is not a prime number, which is correct, 8 is not prime, but it doesn't have to be a prime number. For both of them to be a coprime numbers, they just have to not have not have any common factors other than 1, obviously. They shouldn't be divisible by the same number. 8 and 9 works, 12 and 13 also works, and 1 and any number. So 1 and 8 are coprimes, 1 and 9, 1 and 325, 1 and 1000, any number with 1 is coprimes. We learned that 2 primes are always coprimes, and actually one other rule is that any consecutive numbers are also coprimes. So it could be like 5 and 6, 13 and 14, 21 and 22. So any consecutive numbers are coprimes. And lastly, 1 and any number out there are coprimes. And by knowing these coprimes, we can actually conclude that in rational numbers like 1 over 2, 1 and 2 are coprimes because you cannot further simplify them, because this is the simplest form. So 8 and 9 are coprimes, that's the simplest form, and 12 over 23 would also be the simplest form.